Hello, everyone, and welcome. We're going to get everyone in here from the waiting room, and then we will go ahead and get started. All right, wonderful. Well, thank you so much, everyone, for joining us today. We're so glad you're here for our webinar, Creating Resilient Solutions, Utilizing Geodesign to Minimize Risk. We have three subject matter experts with us today to talk about some different geodesign use cases, as well as some great projects Terracon has done. And on behalf of all of the employee owners at Terracon and Pivvot, I want to welcome you. Just a few housekeeping items before we get started. If you do have any questions during this presentation, you're welcome to go ahead and put them in the chat as we go. We do have time at the end of the presentation to answer all of those. If you'd rather not type it out at the end of the presentation, we also can enable you to unmute your microphone and you can ask those questions live. So to go ahead and get us started, I'm going to go ahead and turn it over to Mo, who's going to kick us off for our webinar.
Oh, thank you, Megan. You hear me all right? Good. And you can see my presentation also, right? Okay, thank you all. Appreciate you all joining this afternoon to learn a little bit about geodesign and instrumentation services that we provide in Terracon. By way of introduction, my name is Mohammed Nasim. I have two co-presenters with me today, Dr. Rabi Yadava and Dr. Sadra Javadi. Before I get into the presentation, I just wanted to start with a safety share. Safety is one of the core practice and values in Terracon. And we start every meeting with a safety note with an objective that all of our colleagues and clients go home safe every day to their loved ones. And in the Eastern Seaboard, where I am, close to Washington, D.C., winter is pretty close to an end. And I think we are somewhat geared towards spring yard work. And the safety note that you see on my screen is geared towards the safety around yard work during spring. Mainly two categories, equipment safety and personal safety. Before we start using our equipment, making sure that they are in safe and working conditions, rightly fueled up. On the personal safety, just make sure that we have the right type of protective gears, the gloves or eye shields, hearing aids we're using, depending on what we're doing. And also we are rightly dressed to avoid any sort of insect bites and tick marks. The premise of this whole thing is what we call pre-test planning. That is to take the time to think about the task we're about to do, whether in a professional or personal level, and making sure that we do it in a safe and manner as much as possible. If things go south, we have some sort of emergency plan in place so that we can fall back on that one. With that in mind, this is an outline of our presentation today. I will provide few slides on the overview of Terracon, and then introduce the services that we provide under the geodesign and instrumentation umbrella. For brevity of time, I'll quickly glance through some of the projects just to give a flavor on some of the capabilities as well as complex situations that we have dealt with in the past. Looking at the attendee list, we see a good number of you are joining from the renewable energy sector. That's why I requested Dr. Ravi Yadav and Dr. Sadr Javadi to present our current services that we provide for the wind and solar market. So Terracon has been in business for 57 years now. We have around 175 offices coast to coast to cover the whole United States. We have around 55,000 employees, and we are completely employee-owned organization. This is some statistics from ENR 2022 data. It's worth mentioning that we are number 11 firm in the top 100 pure design firm in the United States, and our ranking is 44 out of 150 global firms. All throughout the ENR ranking, it clearly presents that we're a significant player in the civil engineering industry in the US and worldwide. This is a list of our market sectors. We have a presence in the federal and oil and gas. We have a strong market share in power generation and transmission. We work in vertical as well as horizontal transmission. We do work in healthcare sector in large-scale hospitals, or I should say medical office buildings. And we also have participation in logistic, retail, and technology sectors. Terracon started its origin in Iowa back in mid-50s as a geotechnical engineering firm. And over the years, it evolved in 4 different types of services. That is including definitely geotech is our core practice, construction material support system. We also provide environmental and we provide facilities. It's a list of items that I'm not going to be reading, but what it is essentially, it evolves from our holistic approach on any project. Every project that we try to get involved, we would like to get it from very initiation to the completion, every life cycle of that project, and also involved after the completion through asset management. So before a client is selecting a site, we do the due diligence. Is the right site for this facilities to be built? What sort of challenges are there? And then we move into the design phase, looking at different design possibilities. We also look into different challenges related to below grade construction, educate our client on those risks, understand different ways to mitigate that risk or reduce that risk. And when it goes to construction, we stay on the project to making sure the design intent for below grade constructions are correctly followed and the client is safeguarded against all possible risk as much as possible. And then when the project is complete, we stay involved in life cycle of that project in asset management. And geodesign and instrumentation is ingrained in all these four quadrants in different ways to assist the client to make sure that whatever they're trying to build, it's being built in a very safe and cost-effective manner. This is a laundry list of geodesign services. We have capabilities to provide support of excavation design for different types of support systems, ranging from very flexible soldier panel lagging to very complex or stiff second pile wall, diaphragm wall, and any other types of wall in between. We have an art retention group that works on different type of grade separation wall in either modular block or MSC wall. We custom place wall. We also have that group working on natural slope stabilization for either in urban areas or rural areas. Instrumentation is a big portfolio that we cover. We have capabilities to work with every possible type of sensors and their integration to monitor of either an ongoing construction or an structure or element in place, and then connecting all the data into a web-based platform, publish it for the project team, and build a trigger system that will trigger when a threshold value is I would say go over, and then a message is sent to the whole project team to do some corrective measures if needed. The foundation design is another capability of ours. Along with traditional foundation, we do significant amount of foundation retrofit. There are two projects that I'm going to present today briefly. And then we also do design of wind turbine and solar pile foundation design. Ground improvement, either for improvement of the soil or cut-off barrier for seepage in the dam or deep soil mixing. We have the capabilities to provide all those type of design along with rigid inclusion and aggregate pier design. We have mixed bag of other services. We have the capability to do very sophisticated, complex, three-dimensional soil structure interaction modeling to understand the component of different aspect of soil and structural interaction. We can do active risk management for large-scale infrastructure project like below grade tunnel. We do dewatering for construction projects, also under slab drainage for commercial building. We do good amount of forensic study to find out if things go south, what exactly is causing an issue, and try to work with the project team to come up with a solution. And as I said, that we do a good amount of structural retrofit for existing buildings. With that in mind, I think I will briefly touch on two of the topics today. The first one is what we call adaptive reuse of existing foundation. In highly built up urban areas like in Washington, D.C., or in maybe New York and LA, we see commonly the client is coming back so that I have an existing three-story building. I want to add 2 or 3 additional levels on top. And there are two challenges there. Definitely, there is a structural challenge that we collaboratively work with our structural engineering friends to come up with some sort of a column jacketing or strengthening of the column to take the vertical load down to the foundation. And then we work with them to see what sort of alterations we can do to support that additional load. The two challenges there is definitely working conditions, because many cases it's an existing building with limited headroom. And the second thing is that what is the load distribution between your existing foundation and the new foundation you're going to implement? So another disclosure is two of the projects that I'm presenting today is with my former employer, but I'm presenting this as a personal experience. The first project I'm going to be talking about is Children's National Medical Center in southeast quadrant of Washington, D.C. It's one of the preeminent children's hospital in the country, built in 1970. This is sort of like a building as it stands now. The portion of the building is 5-story above grade, and the other portion is 3-story above grade. The hospital authority wanted to build the remaining portion to all 5 levels. That means they want to add 2 additional levels on top of existing structure. The first thing is that this is a foundation plan. We started working with the structural engineer, and just to orient ourselves, they're adding essentially 2 additional levels right here and the halfway through the building. And the maximum load that's going to impart is really at the far end of the building, just because of some surgical facilities and HVAC equipment on top, which is close to more than 70% of the existing capacity the foundation had. And what we have, when we talk to the structural engineer, they say that the last 2 column lines, so that's about column line A, which is close to the perimeter of the building, and the adjacent column line B will experience 70% additional load coming onto them. And these 2 column lines are connected by a strap beam. So the design philosophy here is that first we find out what the load can be taken by these existing piles, and then the remaining goes into additional element that would be installed on sideways, typically micropile, and then be stitched to the existing foundation. The first challenge is to understand the condition of the project site. This is an active hospital, need to remain operational for the whole time. So all we were given is 10 column lines to work. All the construction equipments, all the construction activities has to be between that, and the remaining of the garage up to 5th level has to be remain operational. So whatever the design you are coming up with, we have to understand that it can be implemented in that limited headroom situation. The second thing is that what is the load capacity of the existing pile that it can take additional load? Built in 70s, there is no as-built drawings. And then the first to think about what is the innovative way of testing this pile. The approach we took for this particular one is to open up a small excavation on side of existing pile cap, go underneath the existing pile cap, cut a section of the pile, and put a jack there, and use the existing building as your reaction frame to test against at least 100 times the capacity that you're trying to develop. See how much it goes without significant movement. And this is some pictorial presentation of that. This is the cut section of the Scape Raymond tapered pile, which is a concrete infill with a still cylindrical. This is the jack in place. And as you try to jack these things, definitely got to be careful about instrumenting all the surrounding columns, so there is not anything like a bending or slanting of the columns happening because of any of the additional loads. And try to record the data, come back to the drawing board again, and try to figure out that, well, the 30% of this load can go to the existing foundation, remaining 40% has to go into the new foundation. The other project is a Boeing building in DC. Again, built in 1920, it has a very nice terracotta facade. The owner wants to keep the facade, got the whole building down. This has 1 level below grade. They want to add 2 more additional level to maximize their below grade space. We work with the structural engineer. We come up with the shoring system to hold the facade in place. And then we decided to do what we call underpinning piers to support the vertical excavation down. But the issue was that at the depth the underpinning pier were terminating is not doesn't have enough bearing capacity to support the vertical load. So we have to install micropiles to the flanges going down deep into the stratum, which has that load bearing capacity. And at the same token, we also have to install some raker systems, making sure that these below grade walls are in place. The next topic, we're going to talk briefly about underpinning, which is really underpinning of existing foundation that is in close proximity to an open excavation or future excavation. The project is at Dallas International Airport modernization between 2006 and 2011. It's a $2.6 billion master project that involves construction of a new runway, additional parking garage, but most importantly, if you visit Dallas Airport, which is one of the gateway to DC, now you travel to trains. Previously, there was some surface travel system. So airport authority decided to create a tunnel network between the boarding gates and the main terminal or the concourse to making sure that there is minimization of the surface traveling. And to do that, essentially there was a significant excavation of a fully operational airport. This is a close view of that excavation, which is a two-tiered system. It's a shallow bedrock geology. So we have a SOE design on top using soldier pile and lagging to support the soil. But when you get into the rock, we use rock bolting to support the open excavation to facilitate the construction of the tunnel network. The challenge that comes in when it comes to close to the existing concourse, which needs to be operational for the duration of the construction, and the construction of the main station underneath the existing concourse. And the way we sort of facilitate that is to first coming up from the existing concourse to drill in some micropiles using a lacing system to making sure there is no lateral buckling. These are the existing spade footing that was supporting the building. So we supported those into deeper stratum and then started using soil nails to facilitate the construction underneath the building. So excavation underneath the building so the contractor can sort of like construct it. So I was working on the owner side. Ravi Yadav, my co-presenter, was on the contractor side of this particular project. Another challenge was that there was a bridge that was connecting one concourse, I think that is concourse B and this is concourse C, was supported on a drill shaft foundation system. But the depth to facilitate the construction of the tunnel was deep enough for undermining this one. So we installed some micropiles through the existing drill shaft and eventually get the load into the deeper stratum so that the excavation can continue below the bottom of this existing drill shaft and construction of the tunnel. The last project I'm going to talk about is a forensic evaluation. This is a project in Charleston, South Carolina, involved with a new hotel construction. Terracon was a geotechnical engineer of record, and part of that hotel construction involves a sort of like a deck over the water, which was Terracon proposed to do was supported by pre-stressed concrete piles, sorry. And then we left the site around early spring. In late fall, we got a call from the client indicating that the piles that those were installed in early to midsummer has moved away from its original location from 6 to 12 inches. And the contractor is ready to bring the precast slab to build the deck, but construction is halted because they don't have a support system that can build on. So we got involved definitely with the client and with the contractor, reviewed some photos, some videos during the time we left, and the construction begins. And we found out that there's a good amount of stockpile of equipment, stockpile of materials, and also to facilitate construction, the contractor has built a coffer dam. So we took all these scenarios in a three-dimensional solid structure interaction modeling. We model every sequence of the construction. And what we found out is that due to the load that was coming from the equipment stockpiles and the material stockpiles, along with the coffer dam cutting off the seepage path, there was a poor water pressure built up and the soil lost its strength. This is a very soft soil, pretty much not even normally consolidated. So it was basically a soil flow that was happening in a deep-seated way that pushed the pile. Knowing that condition, we work with the client and with the contractor to come up with solutions and with the structural engineer, or what are the criteria to use some of the existing piles, and then what would be the corrective measures in place. So again, in a nutshell, definitely we didn't have enough time to go over other projects, but I will hand it over to Ravi Yadav now, who is going to be talking about wind turbine foundation design. Thanks, everybody.
Thank you, Mo. Let me launch my presentation. Yeah, please confirm that you can see my slide. Okay, and everybody can hear me, correct?
Yes, Ravi.
Okay. Good morning, good afternoon, everyone. Depending upon where you are, I'll be talking about Terracon's services in field of wind turbine foundation. So Terracon in general provide two kinds of foundation. One is called Grip Terra Pier Foundation, which will describe by a video how it looks like, and the other one is the Grip Terra Anchor Foundation. Now, depending upon where the anchorage is developed, is it in the soil or the rock? So we got two different kind. One we call it a Grip Terra Soil Anchor Foundation, and other one we call a Rock Anchor Foundation. So here I'll begin a video about 1 minute 30 seconds. So that will give some idea about these two type of foundation and how they're constructed.
Ravi, is it playing in at your end, that video?
Okay, so So in summary, what you have seen that there are two kind of foundation. One is the pier foundation, which is like a large diameter drill shaft, which has been post tensioned so that it doesn't develop tension from the wind moment. And the second one is similar to a mat foundation, which has been anchored to the ground. The only difference is that in this case, just like a tieback wall, all the anchors are pre-stressed to keep the foundation very tightly held to the ground. Now, when we get a project, so we start with geotech report. We get preliminary geotech report, and we can get the load. Now, once we get that, then what we do is that we try to see what kind of foundation will work. So this block flow diagram helps us to initially decide what kind of foundation might work, but at the end, when we go in the detail, things might change. So let's say we have a condition in which we are looking at a 6 megawatt or larger turbine. In that case, our experience says that we need an anchor foundation. If the size of the turbine is less than 6 megawatt, then we go onto this side and look at the second condition, where is the groundwater? If the groundwater is high, so again, we recommend anchor foundation. The other foundation can be done, but again, they are going to be more expensive. So our experience says that if the groundwater is high, better to go for anchor foundation. Now, let's say the groundwater is low, right? So then we go to this decision box and we say, hey, is it a rock site? Yes, it is a rock site. Then we can have two kind of foundation in that soil condition. Either we can have anchor foundation, which will be, I think, a optimal solution for this kind of situation, because rock is shallow, we can anchor into it. Or for some reason, if the rock is not shallow, maybe slightly deeper, then maybe we can go with this option, pier foundation with collar. Now on this side, if the rock soil is not predominantly rock, then we look at this condition. Is firm hard clay or granular with binder? So basically in the video you might have seen the crane was digging a large hole and you could see there was no support of excavation. So basically what we are looking at is that when we dig the hole for the foundation, can it stand open on its own? We do not plan like in this construction. Generally, nobody goes inside the hole. The work is all done by the excavator. It'll excavate it, and then what we'll do is that the foundation construction will begin. So if we have a clay or a granular material with some binder, it can stand open. Then pier foundation with collar is a good option. If it not, then we go to the anchor foundation. Looking at the economic feasibility, these are some general, I can say this is a general, this could change. So what we have seen is that for per megawatt of turbine, if this way the turbine size is increasing. So you can see that pier foundation, pier foundation is probably a better option because the cost to construct per megawatt is just smaller. Then the second best thing we have is a anchor foundation, and these both have been compared with respect to the spread foundation, and we can see that spread foundation cost per megawatt is slightly higher than these two foundations which Terracon typically design. Now again, this one is not true all the time. It depends upon the soil condition. Now, if the soil condition is very poor, then it's possible that one of these foundation may not follow this path. It may be a little more expensive. Coming back to the environmental impact, the CO2 footprint, as you can see that a spread foundation, they utilize massive amount of concrete for the stability. So that means that a lot of CO2 emission to build that particular foundation type. But when you go to the two foundation which Terracon designs, you can see that they're not much of concrete. There are pre-stressing elements, and the cost per megawatt is less. The CO2 per megawatt is comparatively much lower. In addition to designing new foundation, Terracon also does look at the existing foundation. Now, why do we need to take a look at existing foundation? Number one is repowering. Technology is changing. The turbines are becoming more efficient. So it's possible that they are supporting 2.5 megawatt turbine and the owner wants to install 3.5 megawatt turbine. That means there's a possibility that turbine footprint is bigger and we might expect higher load. So what we do is that we will take a look at the foundation to see if the foundation can support the turbine. Definitely the first they have to go to the structural engineer to make sure that the existing tower can take that load. And once structural engineer says, okay, it comes to us, and then we will perform the analysis as if it is a new foundation. And we'll do a fatigue analysis, all kind of structural, geotechnical design, and come up with the solution. Other option is life extension. Let's say there is a wind farm which is close to end of its life, and then what we do is that we go out to the field, do some precondition survey, take a look at the condition of the foundation concrete, the soil around it, anchor bolt, and then we get the what is called fatigue loading. We compute how much fatigue loss has already happened. And in addition to that, what we do is that we go out with the data acquisition system. We install strain gauges, accelerometer, tilt sensor on the tower, and we collect the data in real time, bring the data which is in a time domain, convert it via FFT to a frequency domain. And from the frequency domain, we can see what are the predominant frequency. We locate the 1P and 3P frequency, and also we locate what is the natural frequency. And once we have all this information, that goes into our further analysis. It could be a calibration of the model, and or estimating how much foundation stiffness we have. So that will go into the detailed analysis of the existing turbine foundation. So that was all about the services we provide in field of wind farm, tall wind farm. And so far, this is slide I put in just to summarize what is the overview of Terracon work in this area. Terracon owns patent pending pier and patented anchor foundations. So we own this design, patent on these designs. So far, Terracon has designed about 6,000 foundations, providing about 15 gigawatt of renewable energy. In last about 10 years, we have taken look at 1,000 foundations for repowering or life extension. So this is the summary of the work which WTG team at Terracon has been doing for last 10-15 years. I think that's all from me. I'll hand over to Satra Javadi to talk about the solar projects.
All right, thank you so much, Robbie. Could you please just confirm you see my screen?
Yep.
All right. Hello, everyone. Good afternoon and good morning, based on where you are sitting at. My name is Sadra Javadi. I'm a geostructural engineer with our Geodesign team based at San Diego, California. Today, I want to go over briefly about our solar projects and the engineering services that we provide to our solar clients. Back to 2017 to 2018 was the point that our company decided to get more involved with the solar business. So dive into this market. So as you can see in this map, right now we are providing the engineering services to our solar client in all 50 states. And as solar business grow by year, our revenue just from the solar projects start growing from about $18 million back to 2018 to a little bit over $90 million back to 2023. So the geotechnical services that we typically provide to our solar client comes into different stages. The very basic stage is a stage one report, and this is the type of report that we are not only providing to our solar clients, but to any other clients that we have. And what it does is that it is a basic information that we gather in this report is based on the publicly available databases, state issued resources, and also Terracon data points, which comes from the projects that Terracon previously performed in the vicinity of the area that is considered for the development. We used all those resources. We come with a list of like basic information about the geology, geohazard, different type of condition that our client should anticipate to see at this site. And we list them in that report, and we provide the basic information to our client throughout that stage one report. The next step is that in some of the sites, we could have some geohazards like karst issue or abandoned mine in the area or within the project site. Or liquefaction hazards, for example. So before we put boot in the ground, we also can provide the additional supplemental study to our clients. We have subject matter expert in all those fields in-house. We can like perform desktop review and site reconnaissance, and we can determine what is the hazards to the projects and provide the recommendation before we move forward with the project. The next step definitely is the field exploration and laboratory testing or field testing. Terracon has developed a table of suggested scope of work specifically for solar developments. That table is based on the acreage or design capacity of the solar sites. We usually recommend our clients to go for 25% of required effort on their preliminary phase. In that case, we can have a little bit more detailed information about the geology or geohazard or the site condition. And then next phase is going to be the design level, and we would cover the remaining 70% of the effort during the design level. Sometimes along with the design level or in a separate phase, we also suggest to do the pilot test program, especially for the solar projects. Pilot test program is very essential from different aspects. Some of the top reasons is definitely gonna give us more confidence about tailoring our engineering recommendation and parameters that would be developed for these sites based on site specific information, and also in many cases help us to adjust the required embedment depth for the solar foundation, which would save lots of money for client. In some cases, our clients may require us to provide the structural analysis and design of their pilot structures for the racking systems. We also have in-house SE structural engineers that they are capable of doing all those analysis. And at the end, like many other projects that we do in Terracon, we also stay with our client during the construction, and we provide any needs for inspection, material testing, or providing consultation with any obstacles that comes along during the construction. As I mentioned, one of the big chunk or important part of services that we provide for solar development is pilot testing. So what we do is that, like, either based on the geotechnical information that we gathered in first phase, we do a basic analysis and we recommend a range of potential required embedment depth for the solar piles. And then based on that, we do pile installation, and we perform like axial tension, compression, and lateral load tests. And after that, we process our raw data and provide the recommendation to the client. So as you can see here, I put together some picture of like the test setup that we do. One thing to notice on the left-hand side, there you see like we are installing two piles. So that's how we typically do pilot tests in-house, is that we propose to like have a shallow embedment and a longer embedment. So we do a range of embedment testing when it comes to the tension, axial, and lateral testing. In this case, we can have enough information from the shallow depths to the longer depth, embedment depth. And then, as you can see, under the axial tension, we came up with our own frame to perform the axial tension loading, which is this innovative frame that we design in-house. It is very easy to carry. It is very, very easy to install, very safe. And so that's a part of the methods and means that we develop in-house. After pilot testing, we usually, like, as I mentioned, we process the data, and then we provide the axial skin friction and bearing and P multiplier to our client. And also we provide the recommendation regarding how they can be efficient during the installation. Sometimes, as I mentioned, again, we are requested to assist our client with the structural design. In that case, we review the information that comes from the engineering reports, and then we are capable of performing L-pile or A-pile analysis for lateral and axial. And then we do the structural analysis using the structural software to determine the shear or stresses, buckling, and all those structural detail. And at the end, we can also provide the drawings and calculation report for use of our clients. The next topic that I'm gonna just touch on it here is that as a part of the Geodesign team in Terracon, there are some opportunities that, for example, some of our clients, they approach us and they brainstorm idea that they have, innovative idea that they have on how we can do things differently or efficiently. We have lots of those clients, and I put one of the examples here. This particular client reached out to us and brainstormed with us about the friction pile idea. Actually, this is a patent protected project. So we help our clients to go over the engineering engineering analysis of what he had as an idea, develop that and standardize it for the use and application for transmission line foundation. So what we did is, as a part of services we offer to this particular client, was we designed a pilot program tailored specifically for this new type of foundation. We did the pilot testing. We processed the data. We used the data obtained from this test, along with the site investigation we did at different project sites, and we used it in the finite element model to calibrate our model. And since then, we are tagged along with our client, and we are promoting this foundation with 100% confidence to our transmission line or utility clients. And based on their need, well, we model this foundation in their project site, and we install this type of foundation for their application. So some of like brief conclusion out of like this particular research study we did is, after all the back and forth we did with our client and did like pilot testing and analysis, and then also observing the installation of this foundation at the real life scenario, we concluded that like definitely this type of foundation is environmental friendly. That's why we are really big fan, and it is very like easy to install it at the locations that it is really hard to access or it is congested. So it is very easy to like go around all those obstacles at the site. Has a very rapid installation rate, and also definitely is cost effective. So since we explore all of these and we concluded, so we are with our client and going after opportunity and promoting this to our client. And this is one out of many research study that we have done so far. With that being said, thank you so much for your patience, and I'm gonna leave it up to attendance to if they have any questions, we would be happy to answer.
Thank you so much. Thank you so much, presenters. We really appreciate it. At this time, if anybody has questions they'd like to ask about any of the content, feel free to put that in the chat, or you can raise your hand and I can come around and unmute you. If you get off this webinar today and think of something you'd like to ask, you can also always contact our presenters, and we'll be sending this recording as well as that video out to you about Griptera. That's really exciting stuff. So I want to make sure you're able to see that. Just give it 1 minute to see if anybody has any questions. All right, we're presenters. I think you did a really wonderful job of explaining everything in a really beautiful way. As always, if you ever have any questions, feel free to reach out. We really appreciate you joining us today, and I hope everybody has a great afternoon. Take care.
Thanks, everybody.
Bye.
Thanks, everyone.